Hello, everyone. Okay, so this video is going to be talking about light. Sorry, Bubby wanted to join me, I think. Have our little helper. Hey, Bubba. Okay, so this video is going to be talking about light waves. So let me go ahead and present my screen. Okay, so the main thing to remember about light is that light travels as a transverse wave, different from a sound wave. Sound waves travel as longitudinal waves, so that means there's a vibration, and that wave is like kind of being pulsed through. Transverse waves are waves that go up and down, okay, like the usual ones that we've been learning about. So light travels as a transverse wave, and light does not need any particles to be able to transfer its energy through. That means that it can travel through a vacuum like space. Okay, sound cannot travel through space because it needs particles to be able to kind of bounce that sound off of. Okay. So, our three big keywords to remember with light waves is how they're able to travel and interact with other objects. So, the first one is that light waves can reflect off of things. So, when light is reflected, it means it's bouncing off of something. Okay? So, we learned about reflection when we used mirrors in class. Okay? That was to reflect light waves off of each other. So when I look at myself every morning in the mirror, I'm seeing all of the light waves bounce off of the mirror and put my reflection back so that I can see myself, okay? Same with this picture here on the top left of the mountain. So the water is able to reflect all of the light hitting the mountain when it hits the water back, okay? In this picture over here, we talked about why we are able to see different colors, okay? So when you're looking at a green leaf, you're seeing the color green because light is coming in. All of the colors of the rainbow are traveling when those light waves are hitting that leaf, okay? It absorbs all of the different colors and reflects the color green back at you, okay? So that's why we're able to see green. That is reflection. The next concept that we talked about is absorption. So that's other ways that light can be taken in. Okay, so in these pictures, I have a sponge absorbing water. Okay, so taking in something. Your skin can absorb lotion, and a towel absorbs baking grease. Okay, so when you're thinking of the word absorb, you're thinking that it's being taken in. So if we look at this picture, this red, orange, yellow, blue, violet, indigo, these colors are being absorbed by the leaf. They're being taken in. It's reflecting back the color green, and that's why we see the leaf as green. Okay, so we talked about reflection, absorption. The last term is transmission. Okay, so when things are being transmitted, that means that things are able to go through them. So when we talked about refraction, okay, that's when light can bend when it passes through a different medium. That's transmission because the light is passing through. It's just getting changed a little bit along the way. So in this picture on the top left, this is a light wave passing through a prism. So a prism is just like a lens, okay? Something usually made out of glass that allows light to bend through, okay? Because this prism is a solid. Right now, the light wave is passing through air into the solid. So when it goes through the solid, it bends the light, showing the rainbow. In this picture here on the bottom left also shows refraction. I feel like that was like a nice easy way to see like that bent shape. So light is traveling through the air. Now through this glass prism, it's being bent and then back through the air again, okay? And notice how the light is traveling so straight. Even when it's bending, it's going in a straight line, okay? That's because the frequency is so high when light waves are traveling that it keeps it kind of in a straight line. Okay, so in this middle picture, This is an example of light transmission, okay? Light is being transmitted or going through the window so that it brightens up your bedroom. And then our last picture, we've talked about refraction a lot. This is a picture of refraction, and so are these. So refraction is just when light is bent when it passes through a different medium. So, for example, this straw in the glass is going through air, then is passing through the water. This is what makes it look bent because it travels at different speeds when it goes through different mediums. Okay, so I have a Amplify simulation attached to this video if you would like to, test out what kind of things can happen when light energy is hitting different things. So right now I'm just going to walk you through how to get to the simulation, and then you guys can be, free to explore. Okay, so here's the link. So when you get to the Amplify page, you're going to scroll down to grades 6 through 8. Okay, you're going to continue as student, get started, say you're not a robot. Sometimes you have to prove that you're not a robot by clicking those little squares. I didn't have to do it that time. Awesome. Okay, so then it'll bring you to the Amplify page so that you can see everything. So to get to our simulation, you're going to go to these little 3 bars in the top left. Okay, so when we click that, okay, it's going to show all of the simulations that we can use. So we are going to scroll down to the light waves simulation. Okay, and then this will load up. So you have 4 options of what you can do. You can turn on the sun, you can make it a light bulb, a laser, which you can change the different colors of the laser, or you can do a custom, because remember we talked about the electromagnetic spectrum, which is how electromagnetic waves travel. So you can set it to a wave if you want. You can have it green light. You can set it to red light if you want. And you can see this is how we tell the difference between the colors, because the wavelengths are different. This is violet. This is green. This is red. Okay, and then if you want, you can also change it to the different types of waves. So if you want to see how microwaves can affect a material, or maybe like gamma rays, how that can affect a material. So you can go to that if you'd like. For teaching purposes right now, I'm just going to deal with, let's just do the sun. Okay, so you can turn your energy on, and this will make the light wave. So I want you to toggle, which means to click the buttons, show beam, and I also want you to toggle on showing energy. Okay, so this is how where energy is traveling. Right now, it's going through a straight, it's going as a straight line. So you have some of these materials that you can put through, like glass. Okay, this would be an example of light transmission, right? Light is traveling through a solid. And it's also probably some sort of refraction, because the light waves can be bent as it's traveling through the air and then through the glass. You can hit this inspect button, which will kind of tell you the effects that can happen to the glass afterwards. So like before and after, obviously, the more sun that's going to beat down on your object, the temperature is going to change. It's usually going to get warmer, right? So that's how you can kind of see how light travels through that. You can put different sorts of, molecules in there, genetic material, DNA. So like how can a lot of light, how can it affect the way that we're made up? Because we know from the news and from our, things that we've learned in school that you don't want to spend too much time outside in the sun because you get sunburn. So this can tell you what can happen after a lot of sun damage. Okay, so this is for you guys to play with. And if you find something really cool on this, I would love it if you could email me, and maybe I could share it with the rest of the class. Okay, so you guys really can have a lot of fun and increase your understanding about light waves with this simulation.